Hello and welcome to this Jupyter Notebook walkthrough on natural language processing for absolute beginners. In this notebook, we will be exploring the basics of NLP using the Transformers library and sentence piece. The first cell you see here is a markdown cell that provides some context for the notebook. It also includes a pip install command that installs the necessary libraries for our NLP tasks. Moving on to the next cell, which is a code cell, we will start by importing the necessary libraries. We will be using the Transformers library, which is a state-of-the-art natural language processing library developed by Hugging Face. We will also be using the sentence piece library, which is a library for subword tokenization. Let's take a look at the code in the next cell. In this cell, we are importing the T5 tokenizer and T5 for conditional generation classes from the Transformers library. The T5 model is a transformer-based language model that can be used for various NLP tasks such as text summarization, question answering, and language translation. The T5 tokenizer class is used to tokenize the input text into subwords, which is necessary for the T5 model to process the text. The T5 for conditional generation class is the actual T5 model that we will be using for our NLP tasks. We will be using these classes in the upcoming cells to perform text summarization. In this cell, we are performing text translation using the T5 model. We start by defining the input text that we want to translate, which is translate English to German, the weather is good. Next, we create a T5 tokenizer object and set some parameters such as the maximum length of the input text and the maximum length of the model output. We then use the tokenizer to encode the input text into subwords and convert it into a PyTorch tensor. After that, we create a T5 for conditional generation object and load the pre-trained T5 model. We then use the model's generate method to generate the translated text. We set the minimum and maximum length of the output text to 4 and 32, respectively. Finally, we print the translated text, which is Das Wetter ist gut. In this case, in the upcoming cells, we will be performing text summarization using the T5 model. In this cell, we are using the pipeline function from the Transformers library to perform text translation. We create a pipeline object for translating English to German and specify the pre-trained T5 model that we want to use. We then use the pipeline object to translate the input text the weather is good. The translated text is returned as a list of dictionaries, with each dictionary containing the translated text under the key translation_text. Finally, we print the translated text, which is Das Wetter ist gut. In this case, this is a simpler way of performing text translation using the T5 model, as we don't need to manually tokenize the input text or generate the output text. The pipeline function takes care of these steps for us. In the upcoming cells, we will be using the T5 model for text summarization. In this cell, we are using the T5 model for text summarization. We start by defining the input text that we want to summarize, which is stored in the variable body. We then pre-process the input text by adding the prefix summarize to it, which tells the T5 model that we want to perform text summarization. The pre-processed text is stored in the variable preprocessed_text. Next, we create a tokenizer object for the T5 model and specify the maximum length of the input and output sequences. We then use the tokenizer to encode the preprocessed text into tokens, which are stored in the variable tokens. We then create a T5 model object and use it to generate the summary for the input text. We specify the minimum and maximum length of the summary and pass in the encoded tokens as input to the model. The generated summary is stored in the variable outputs. Finally, we use the tokenizer to decode the summary from the encoded tokens and print it out. The generated summary is craters formed on the lunar surface from previous meteorite collisions. Craters are a random event, but their frequency obeys probability theory laws. Craters are a vital part of lunar science, and can help assess danger to the Earth. In this cell, we are using the Hugging Face pipeline to perform text summarization using the T5 model. We start by importing the pipeline function from the Transformers library. We then create a summarizer object using the pipeline function and specifying the summarization task, the T5 model, and the T5 tokenizer. The summarizer object is stored in the variable summarizer. Next, we pass in the input text body to the summarizer object along with the minimum and maximum length of the summary we want to generate. The generated summary is returned as a list of dictionaries, with each dictionary containing a summary_text key and the generated summary as its value. Finally, we print out the generated summary by accessing the summary_text key of the first dictionary in the list. The generated summary is a meteorite collision is a random event, but its frequency obeys probability theory laws. The lunar surface is an ideal book in which the events of the last tens of thousands of years are recorded. At least 220 new craters have formed on the Moon over. In this cell, we are printing out the possible tasks that can be performed by the T5 model. We start by iterating over the task-specific parameters in the model configuration using a for loop. For each task prefix, we print out the prefix followed by its corresponding task-specific parameters. In this case, we can see that the T5 model can perform text summarization as well as translation from English to German, French, and Romanian. The task-specific parameters include options such as early stopping, maximum and minimum length of the generated text, number of beams to use during generation, and a prefix to add to the input text before generating the output. These parameters can be customized to fine-tune the model for specific tasks. In this tutorial, we have explored the T5 model and its capabilities for text generation tasks such as summarization and translation. We have seen how to load the model, pre-process input data, and generate output using the Hugging Face Transformers library. We have also discussed the task-specific parameters that can be customized to fine-tune the model for specific tasks. With this knowledge, you can now use the T5 model for your own text generation tasks. Thank you for watching this tutorial, and I hope you found it helpful. If you have any questions or feedback, please leave them in the comments below.